Hi guys, today we are on pages 33 and 34 and we're going to focus on dilating our quadratic function. So on Monday we talked about how to translate it. So we slid things left and right and then we slid things up and down. And so today we're going to talk about dilating. Just like if you go to the eye doctor and you dilate your eyes, it kind of changes the size of your eyeballs or your pupils. And so today we're going to talk about how can we make the size of our quadratic, our parabola, different shapes or different sizes. Okay, so dilations are another way to transform quadratic functions. In a dilation, the parent function is multiplied by a given value, and it can be represented by y equals a, and then we are just multiplying that by our parent function. And then the only thing is that a is not multiplying by 0 right now. Okay, so the first thing is the graph of f of x equals x squared is shown. So this is our parent function, and we're going to use our graphing calculator to complete a through c. So the first thing is we are going to graph g of x being half x squared, and then h of x being 2x squared. So right now, I want you guys to use your graphing calculators or use Desmos to plot both of those points. Okay. So y equals, and we're going to do half x squared first. Okay, so then I'm going, if you're using your graphing calculator, you can go to your table. I know there's 0, 0, 1, or there's 2, 2. And I'm going to zoom in a little bit just so I can see a little bit more. Looks like right there, 2, 2. Looks like 4, 4, 8. Okay, so I'm going to plot. I'm going to use a different color. Okay, so A is going to be red for me. So I am going to plot 0, 0. I'm going to plot 2, 2. I'm going to plot 4, 6. I'm just going to make sure that is correct. 2, 2, 4. Oh, it's 8. Oh, silly me. 4, 8. Okay. Again, to get to your table, you could hit the little settings button and go to that. So if I want to know what 4 is, I could go down here and type in 4 and see that it is 8. Okay. I also see that 1 is half. Okay. And then I'm going to make it symmetrical. So I'm going to make it symmetrical right here. And then 4, 8. I'm going to graph it. And I'm going to label it with a G. All right. Next, we are going to do 2x squared. So I'm going to X out of this one, and I'm going to do y equals 2x squared. Okay. And then again, I can go to my table if I want to, and I see it's negative 2, 8, negative 1, 2, 0, 0, 1, 2, and 2, 8. Okay, so I'm going to use a different color. Okay, so it is still 0, 0, but it's 1, 2, and then 2, 8. And I'm going to make it symmetrical on this side. Make it pretty. And I'm going to label it with an H. So those are my two colors. Okay. So it says for each function, list the value of A and describe what happened to your graph from the parent function. So for the first one, it was red. For g of x, the A value was 1/2. Okay. If I look at 1/2 compared to the parent function, it looks like it kind of got a little bit more wide. So I'm just going to say wider. Right? Then for the h1, the a value was 2, and it looks like from the parent function, it looks like it got skinnier or narrower. Okay, and that's exactly what an a value does. Okay, so if you have a number out in front of a square, it will either make it narrower or it will make it wider. Okay, so if you have an a value that's larger than 1, and it would look like a f of x, it is going to actually vertically stretch it. Okay, and if you look like the 2, it stretched it and it made it skinnier or narrower. Okay. Then for the other one, when we had a value like 1/2 that's in between 0 and 1, it actually compressed, instead of stretching it to make it skinnier, it actually compressed it down to make it wider. So this is called a vertical compression. and it makes the parabola wider. Okay. Again, I would make sure you write this stuff down because I would probably go back to it a lot just to make sure you understand the difference between the two. Okay, the graph of f of x equals x squared was transformed to create r of x. So this dotted one. Use the graph to answers 2 and 3. If r of x equals n times f of x, what is the possible value of n? So first, let's just look at what happened. So it looks like, here's the original one, and it looks like it got wider. Okay, so if I think of wider, it has to be a vertical compression, made it wider, and that means it has to be a number in between 0 and 1. Okay, so while this is a fraction, this is actually larger than 1, so I think it has to be 1/3. Okay, then number 3, identify the key features of r of x and then circle the features that are the same for the parent function f of x. So looking at my vertex, it is 0, 0. Looking at the parent function, that is the same exact vertex, so that's cool. The axis of symmetry, where it's symmetrical, is at 0, which is the same as my parent function, which is cool. My domain, again, it goes left and right forever, so that's all real numbers. And that is also the same as the parent function. And then the final one, my range, is everything above 0 on my number line. So y is greater than or equal to 0, which is actually the same as the parent function. So all of these had key features that were the same as my parent function. All right, Alicia will transform the parent function to create p of x equaling 5x squared. Should the parabola for p of x be narrower or should it be wider? So when we're looking at this, we need to look at the a value, okay? So the a value is 5, okay? And that number is, we're asking ourselves, is it in between 0 and 1 or is it completely larger than 1? And 5 is larger than 1, so it will actually stretch it and it will be a narrower function. It'll be narrower, and that's because the a value is larger than 1 because it's 5. Okay. If Alicia changes her a value to -5 so that p of x equals -5x, what additional effect would this have on a graph? Okay, and if you don't know where to start, go to your graphing calculator. Do y equals 5x squared. Okay, it's very narrow. We did what, that's right. Y equals -5x squared. And look, it flips upside down. Okay, so if you knew that right away, awesome. But the additional effect would be that it would be reflected or it would point down. I can't type, point down. All right. Next, on page 34, we can also use a different type of dilation, which is when we have our function f of x, but we actually multiply our input by a scale factor, okay? And that will actually dilate it a little bit differently, okay? So what we're going to do is the same exact concepts. We're going to plot r of x equaling 1/2 x squared, so it's in the parentheses with the square, and then 2x squared, where the 2 is inside the parentheses as well. So we are going to sketch and label the graphs like we did before. Okay, so we're going to go to Desmos or our graphing calculator. Okay, and the way I'm going to type this is a little bit different. So I'm going to use parentheses. I'm going to do 1/2, get out of the fraction, x. I'm going to finish my parentheses, and now I'm going to put a square. Okay. Now I'm going to go to my table because I want to look at my table. It has the points that I have. I kind of want to do a little bit more. So I'm going to try -3. That's the decimal, -4, -4, 4. I'll try -5 and -6. Okay, so I'm going to use -6, 9. Okay, I'm going to use -4, 4 and -2, 1. Okay, so -6, 9. -6, 9 right here. Okay, I'm going to use -4, 4. Use -2, 1. And I'm going to use 0, 0. And then I'm just going to make it symmetrical. So I'm just going to do basically the same thing. Beautiful. Okay, and I'm going to label this with R. Okay, now I'm going to pick a different color, and I'm going to do 2x squared for the next one. So I'm going to X out of that. Or you could keep it up there, y equals parentheses 2x. But again, I want to square it outside the parentheses. Okay. Again, if you want to look at ordered pairs from there, or you could pick the table. negative 216, negative 1, 4, 0, 0, 1, 4, and 216. Okay, so negative 1, 4, negative 216 is way up there. I'm just going to kind of put a dot so I at least know it's up there. Okay, and it is super duper narrow. And we're going to label that with an S. Okay. For each function, list the value of b and describe the effect it had on the graph. Okay, so for this first one, our b value, what we multiplied our input was by was 1/2. Oopsie. 1/2. So our b value was 1/2. And if I look at just the parent function, it actually got wider. Okay. And then the other one was our b value was 2. Okay, our b value was 2, which if I look at the parent function, it got very, very wide, or excuse me, very, very narrow. Okay. So when we have something and we multiply our input by something, so like a bx, okay, that is, instead of it being a vertical shift or a vertical stretch or a vertical compression, this is a horizontal compression or horizontal shift. So if I am compressing horizontally left and right, it does actually make it skinnier or narrower. So if our b value is larger than 1, it will be a horizontal compression. And if I compress something left and right, it actually makes it skinnier or narrower. Okay, and then if I do this other way, if I stretch it, it is going to make it wider. So if you have a b value that's in between 0 and 1, it will be a horizontal stretch, which then makes the parabola wider. Okay, so again, just different things. We can do it vertically, which means we have an a value, we're multiplying a function by a, or we have a horizontal dilation where we're multiplying our x by a b value, and that would do something else. Okay, still, again, it's making it narrower or wider. All right, Carla graphs the function 1/2 x squared, and Marcus graphs the function parentheses 1/2 x squared. Which student's graph will be wider than the parent function? Okay, so what I'm going to do is I'm just going to graph it because why not? So I'm going to get rid of all these. Okay, I'm going to first graph the parent function, which is this one. Okay, and I'm going to graph 1/4? Yeah, 1/4 x squared. Or x squared. So that one made it narrower. Okay, and then I'm going to do the same thing, but I'm going to do parentheses, and I'm going to put the square. Okay, and that one made it wider. Okay. So again, just making sure you look at your colors. The purple one is the parent function. The black one is the this one, and the red one is the most wide one. Okay. So which student's graph will be wider than the parent function? Well, both of them actually. Okay. And if you look at it, this is an a value. If you go to a value, it's in between. It would make it wider, vertical compression. This one has a b value of a fraction, which also makes it wider. So you can also use your notes without graphing it. Okay. Number 9, the graph shows f of x equals x squared. Joe sketches g of x, which is negative 4 times f of x minus 1. Did he correctly sketch the graph? Okay, so I'm going to first look. This right here means we have an a value of negative 4, which means it should reflect it, should flip it down, and it should make it narrower. Okay, this minus 1 part, okay, remembering from the other day, that should shift it down. Okay, so if I look at the parent function, it looks like it did flip over. Looks like it did go down 1, but it does not look like it was correct because a 4 should make it narrower. So I'm going to change colors and I'm going to say no, it should be narrower. Okay. All right, Octavia will transform f of x equals x squared to create the functions described below. Write a function to represent each of the following. So first we have the function a of x will be a vertical stretch by a factor of 7. So again, you can use your notes. We're doing a vertical stretch, which means we have an a value that is larger than 1. So we're putting a number out in front of the f of x. Okay, so it should look something like a of x. You can write it two different ways. You could do 7 times the f of x, 7 times the f of x function, or since we know f of x is x squared, you could also write it as 7x squared. Okay. This one, b of x is a horizontal stretch of a scale factor of 4/5. So horizontal stretch, which means we have a b value, okay, which means I'm going to have something in my input. Okay, so b of x should be f of 4/5 x, okay? Or since we know f of x is x squared, we could also write it as b of x equaling parentheses 4/5, oopsie, forgot the x, and now we can square it, okay? Both of these are accurate, and I would make sure you understand both of them, okay? Which of the functions above will have a graph that is narrower than f of x, okay? So if I think about making something narrower, I think of stretching it. So this would be a vertical stretch. A horizontal stretch would actually make it wider. So that would be just a of x being the one that would make it narrower. All right, final question. A through D gives descriptions of transformations of f of x equaling x squared. Match each description to its function. Okay, so let's just first look at all of these problems. Okay, so I see a negative 6x squared. So I know it's going to have a reflection. It's going to go down. It's going to flip down. And it looks like it will be vertically stretched. Okay, reflection over the x-axis and a vertical stretch. So it looks like it has to be B. Okay, this one we have parentheses, so I'm thinking horizontal, okay? And if I think of 9x squared, that is going to be a vertical compression, which means I am, horizontal compression, and it is going to make it narrower. Okay, so it'll be a horizontal compression. Okay, because it has a B value, not an A value. Okay, R of x equaling 2/3 x, so the number is out in front, so it should be a vertical something. And if it's less than 1, I am vertically smushing it, so I'm making it wider, so it is a vertical compression. And then this one, I see a negative, so it means it has to flip over. We have a B value, and so if I look at my V value, I'm thinking horizontally. I'm either stretching it horizontally or am I compressing it horizontally? Okay, again, you can use your notes. If it is in between 1 and 0, I am stretching it horizontally, which does make it wider. And that would be A. Okay. Again, the way I remember it is if you have fractions like in between 0 and 1, it's going to get wider somehow, okay? If you have whole numbers like larger than 1, it's going to be stretched. It's going to be narrower. Okay? And then I just have to remember, is it an A value, which means I'm doing this vertically, or is it a B value where it's in the parentheses, and that would be a horizontal stretch, okay? So for today's practice is page 35 and 36.